In this next section, we're going to talk about the second of the three major fossil fuels, which is oil. Crude oil, which simply means unprocessed oil, is usually a black or dark brown liquid, although it can be other colors. This is composed of hydrocarbons. Oil is the most widely used of the three fossil fuels. It's responsible for about 31% of global energy production, and it's primarily used for transportation as a primary energy source. Oil is also used as a raw material for manufacturing of plastics, synthetic fabrics, synthetic rubber, and much more. Just like in our last section, when we talked about coal, we're going to go through a bit about how oil is extracted from the earth, how it is processed, and the consequences of its combustion. So, oil is drilled out of the ground from both onshore and offshore wells. Onshore means on land, offshore means in the ocean. Of these two methods, onshore is much more common because, as you can imagine, offshore wells are much more costly because they involve building platforms or erecting rigs that float on the water in order to drill and maintain the well. Offshore wells can also require the drilling to occur at great depths under the ocean. Offshore drilling rigs may operate at ocean depths of 2 miles or more. Once the crude oil is extracted, it gets transported via tanker ship, train, or pipeline to a refinery. Each of these methods of transporting oil have their own risks of leaks and spills, and we'll talk about that at the end of the section. The bottom photo is of the Trans-Alaska Pipeline, which runs 800 miles from the Arctic Ocean to the Gulf of Alaska. Once the oil makes it to a refinery, the first step in processing it is called separation. Separation is necessary because crude oil is not just made of one type of hydrocarbon. For example, water is H2O, it's just one molecule. But crude oil is a blend of various hydrocarbons and also contaminants that are mixed together. So during separation, these various hydrocarbon molecules are separated from each other through a process called fractional distillation. Fractional distillation relies on the fact that smaller, lighter weight hydrocarbon molecules have lower boiling temperatures, while larger, heavier hydrocarbon molecules with will have higher boiling temperatures. Therefore, when you boil a batch of crude oil, the stuff that evaporates first is the lighter weight hydrocarbons, like gasoline, for example, and then once it is vaporized, you can collect all that gasoline vapor and cool it down and condense it so you can have just that one pure type of hydrocarbon, which has been extracted from the blend. And if you keep increasing the heat, the next smallest hydrocarbon fraction will evaporate next. And it can be condensed and collected, and then eventually you're left with just the heaviest fraction, which includes molecules that are used to make paraffin wax and asphalt. So this is how crude oil is initially processed. The second step is called conversion. During conversion, certain fractions that were obtained from the fractional distillation are transformed into other products. This can happen in a few different ways. Cracking involves breaking large hydrocarbons down into smaller ones. That's what you see represented in this image here. Unification is the opposite, combining smaller hydrocarbons into larger ones. And then alteration involves rearranging the parts of the molecule to create different forms from the same set of atoms. And the purpose of this step is to create different molecules that serve different purposes. The final step is treatment. Treatment removes impurities such as sulfur, nitrogen, and water from the various fractions that were distilled and converted. It also involves combining different ratios of the fractions to create products. For example, gasoline that has different octane ratings, which are those numbers that you can see on the different pumps that correspond to regular, plus, or premium gasoline. Those different types of gasoline are made by combining different ratios of hydrocarbon fractions. The most common products that come out of the treatment process are gasoline, diesel, heating oil, jet fuel, waxes, asphalt, and feedstocks for product manufacturing, meaning the raw material that goes into making things like plastic and synthetic rubber. So that's how oil is obtained and how it's processed. What about its impacts? First, we'll talk about the impacts of oil drilling and transport. Just like coal mining can disturb ecosystems, oil drilling can as well. Erecting onshore oil wells and offshore rigs, as well as the infrastructure that has to be created to transport oil, like pipelines and roads, can all contribute to ecosystem destruction. In addition, all of that infrastructure often results in the pollution of soil and water. But the routine sort of pollution that comes from this infrastructure is a drop in the bucket compared to what happens when there is an oil spill. Oil spills can originate from accidents at wells, with tankers, or with pipelines. Spills that occur at sea are more damaging than ones on land because the water disperses the oil very efficiently. So oil spills are more difficult to contain, and they can spread hundreds of miles and cover the water surface with a layer of oil that is very harmful to marine organisms. It can kill seabirds, mammals, shellfish, and other organisms that get coated in the oil. To give you an idea of how dispersed the effects can be, the British Petroleum, or BP, oil spill in 2010, which is what's pictured in these photos, released 134 million gallons of oil and coated 1,300 miles of U.S. coastline in the Gulf of Mexico with oil. That's not to say that onshore oil spills aren't also very problematic. Pipeline accidents have spilled an average of 76,000 barrels of oil per year since 1986, and the largest land-based oil spill in Asia, the Mingbulak oil spill in Uzbekistan, involved a well blowing up and spilling 2 million barrels of oil, which burned for 2 months. Of course, the environmental impact of oil is not limited to those tied to its extraction and transportation. Oil combustion also has environmental impacts. Unsurprisingly, these are largely the same as the consequences of coal combustion. The burning of oil products emits a number of criteria pollutants, including carbon monoxide, sulfur dioxide, nitrogen oxides, and particulate matter, which are not just harmful for the environment, but also for human health. And of course, oil emits carbon dioxide, which is not considered a criteria pollutant, but it is the significant driving force in the enhancement of the greenhouse effect and climate change. In the next section, we'll be turning our attention to the third and final fossil fuel type, natural gas.